Swayam Prabha. Digital India. Educated India.
Okay, now we go to the problem which we want to discuss, which is the two-span bridge. And you remember this, we had 16 activities in the two-span bridge, and we had actually talked about how do we calculate the duration of these activities, and where we took, for example, this was the construction of the pile cap. We talked about the various sub activities involved in the pile cap, okay, and then went on to calculate the duration. And you can see from here we have, this, any questions on this, because we had done this mostly from a PowerPoint perspective. But if you have any questions at this stage, I'll be happy to discuss it, and then we move on to actually using these durations. So just take a look. If there are any questions on this, ask me. Let me clear the board meanwhile. Any questions on this issue? No. So we will take the durations as this, which was given, okay, which we came up with in the last class. And I had asked you a question. I'd asked you to draw the network, do the analysis, and we said, are there any changes and ways we go about the network analysis? So if we actually go back to the bridge, remember this network is our base network, and we develop this network based on what assumption? Right, it's written there, its resources are all available. So that is why we can do, for example, 3, 6 and 9 are only dependent on delivery of piles, okay, or any of this, okay, is all dependent, we are assuming. So then that means I should have piling rigs, I can have piling rigs at 3, 6 and 9 operating simultaneously. So if we now take this network, so what I want to do is now that we have a group of activities which we can relate to, they are not just A, B, C, D, okay, let us now do network analysis with these durations. We'll assume these durations are acceptable. If I go to, depending on the project, I go to some other project which someone is doing with a different method, they might say no, this is not the duration I want, or what, they might come out with different values for specifics here, but we'll assume these are the durations which you are going with. And let us see what the project duration is, okay, let us see what the critical paths are, how patterns evolve, and you will see that once we do this calculation, we'll be able to kind of want to try to do this in a, let's see what are the techniques we would use to reduce the project duration. So let me get this network on. So you can also kind of tell me what the network is, so that we can get this. So I have a start, I have 2, 1, predecessor, successors to 1, 3, 6, 9, 3 goes to 4. Okay, so now what is this chain of activities? This is the abutment and things like that on one side. Okay, from 6,
7 to
8,
8 to 30, and 12, and also 12.
okay, same. So now this is the
8 goes to 12 as well.
Yeah, 8 goes to 12. And what is this series of activities?
This is the west side of it.
This is the center.
Central.
This is the center here. Okay, so this is a series of linked activities which are the east. This is the series of linked activities which are the west. Then I go 9 to 10, okay, 11 to 13, and then 13 to 15, 12 to, and both come to 60, and 2 to 12, and 2 to, okay. So this is the network, and if we actually quickly, I mean, not so that we are not just dealing with numbers, relate the activities. This was the deliver piles, okay, this was the precast beam, okay, this was the pile driving, okay, this was pile cap on each of the sides, this was the abutment, the pier, the placing the beam, you needed the abutment, the pier, and delivery of beam, okay, the delivery of beam, the abutment, the the pier, the abutment for the other side, the laying of the deck, and then fine, finishing of the road. Okay, so I hope we can relate to these activities as we go. Okay, we should not just look at them as numbers. So we would start with, now I'll put out the durations which I have. Okay, so this was 15. This we had 2 durations for each side, but I am taking the final duration, which is 20. Okay, drive pile east, which was 3, is 12. Okay, let me go in the sequence. Then this was the east pile cap, was 8. The east abutment was 36. You don't have these values, do you?
No.
6. Okay, drive pile center was 6, construct center pile cap was 7, and the center pier was 27. West was 12. Okay, we have symmetry here. West pile cap was 8, and this was again 36. Okay, placing the beam was 7. Deck slab was 15, and lay road was 25. Now, without any network analysis, you saw the project. What do you think will be critical in this project? So how many main paths do we have?
3, 4.
We have 4. Yeah, we have one going through 2. We are going 3, 4. We have like 4 main paths. Intuitively, what do you? Can you make a call?
6, 7.
Do you think this will make a impact? No. So this is, I mean, I'm just trying to bring out your intuition rather than just look at the numbers. This will not make an impact. You have 2 sides and the center. Which do you think will be more critical? Center will be more critical, except for, we'll see. Okay, we'll see if if the center is more critical. Only thing, when you look at the durations, remember the center has, see, this is 12, this is 6, 8, 7, 36, 27. Depends a lot on the relative durations. Okay, and remember, in this we are hitting all of the fronts parallel. So it will really depend on, which front. It's like a race between 3 construction teams. It looks, so who is going to control the network? The one who reaches last.
Limiting.
Okay, the one who reaches last. So that will depend on how much time each of these take, and so that is a basic intuitive call. Okay, as the network gets more complex, it might be difficult to make this kind of call. You might have to go based on heuristic of, for example, form work is always a critical activity on structure. So things like that. But let's go ahead with the analysis. Okay, so we have okay, so I have this in a table, but let's kind of work it out on the board. So that this is my start activity. I'm going with again 0, 0, 0, 20, 15. So my piles have been delivered. 15, 21, you will see a pattern emerging.
27, 30, 21, 28.
How much is that? 50? $71. Okay, this one all the predecessors there. Okay, actually, yeah, 71. Okay, so again, because it's a network which we can see, we should be able to find the criticality of the paths. So what is your observation? Two critical paths. Okay, two critical paths, because we are trying to do them exactly the same way. Okay, and the middle path, the only reason it's not critical is because the durations are less. Now, if that pier construction was in water and I had to do dewatering and this and that and a lot of other things which made this higher, then you would have had probably a single critical path through the middle, because the others are different. Okay, and remember, this is again no resource constraints. We are going through it in a single sequence. Now let's go back. 118, 93. Actually, I'm going to change color on you here. I should have like using a different color for this so that we can see what's. Okay, it's pretty straightforward, because so far, and all through here and through here it will be just the same, because there is no float. Only when we come down this, there is going to be any float, and of course this path. 71. Okay, so how late can I start? 44. Okay, let me finish this part. So the next one, this one is 44.
37.
Okay, so 6 goes down to 31. Now here 71,
15.
so coming down here again 71, 35, 15, 15, 0,
71.
71,
51.
50. Okay, so the network is we have the early start, early finish, the late finish, the late start. Okay, and we can see that, like we discussed before, the critical path runs through, and you have two critical paths in this case. Going up.
5 to 12.
Okay, so in all of these activities there is no question of float, and only the float will only come for, so when we take 2, 51 is the total float, 51 free float, 51 0. Okay, so 71 0 20 51, which means there's a lot of Okay, we come down this. Okay, let's start with, yeah, no, so we'll take 6, 16, 0, 16, 0. This would 16, 0, 16, 0. Okay, now will A have any, is it 16, 0? 8.
16 total float is
Total float is 16. What happens if I delay 8? What happens to 13 or 12?
nothing happens.
Nothing happens. 16. So all of it is free float.
Free float, yeah.
0. What about independent?
Independent also
44 minus
0. Okay, because it's, yeah. So this is, yeah, nothing else is there to solve. So let's are there any questions on the analysis? I think should be straightforward, and I think you get a physical feel of what is important on the bridge. Okay, and again, kind of accelerated construction. Let us say we want to reduce the duration. 118 is too much. Let's say we want to reduce it to 100. What would we do?
I'll be allocating more man-hours on some units.
Yeah, so right now, is there any further parallelization one can do on this? Can I see, I'm precasting the beams, and they are anyway not, because of that, see, if I had to cast the beam in place, that would have added one more activity here. So by precasting the beams, I'm doing parallel. Okay, I could probably do something like some kind of a deck here which I could reduce time. Anywhere, whatever I'm talking about, the only way I can't change the construction method so drastically in this particular case. I could probably parallelize some of my road construction. Instead of waiting for everything to get over, I could say that okay, I'm going to start road construction in a particular phase, and then only do say 10 days of road construction which is over the bridge. Something like that I could probably. So again, parallelizing is one way. Other way is simply to reduce the duration of, which means more resources, different kind of materials. So all of these I could say, so if you'll see 36, 27, this is probably the largest duration activity, right?
Yes. Yes, sir.
So I could start, which is controlling and on critical path. So if I can, I mean, it will be probably easier for me to get a chunk out of 36 than out of 8. Okay, so I would look at trying to reduce duration of these 36. I try to reduce duration of 25, 15. See if I can, and we will take this up later. How do we compress the project? Okay, any questions? Now we are going to do the same analysis but with resource constraints. We want to model the resource constraint in the network, and when you do that, we can then compare how the critical path changes and what happens. Okay, so this is probably the one alternative, and if we go into the real world, all parallel is rarely used. Okay, only on probably the most urgent of projects that we would even consider using.